Grade 11 or grade 12, we'll be doing a topic known as financial mathematics, lesson number 1, for which we'll be focusing on simple and compound interest. Now, I've given you that A stands for the accumulated amount, P stands for the principal amount, and then I for the interest rate, and then N for the number of years. So the formulas are given as for simple interest, it's A is equals to P1 plus I multiplied by N. It's a formula for simple interest. And then for compound interest, the formula is A is equals to P1 plus I exponent of N, for which we use simple interest for higher purchases. Example, for higher purchases, and then we use compound interest for the inflations. When you see a question mentioning the inflation rate, know that you're going to use a compound interest formula. Let us look at and also the loans, that is where we use the compound interest formula. So let's look at the following. Compound interest. We've got different compounding periods. So you have to be careful of this. So when they say compounded annually or annually, compounded annually, what they mean? I did not write annually correctly. Okay, it's fine. Annually, it means you take your interest, you say I is equals to the rate R all over 100, you divide by 100, and then when they say to you compounded semi-annually, it means your I is equals to R all over 200. Why am I using 200? It's because of, you are going to say, for example, when you have 5% and then they say compounded semi-annually, it's you're going to divide by 2 actually. But now, to avoid long processes, I'm going to say 5 over 100 because of it's a percentage, divided by 2. You divide by 2 for semi-annually. It's 6 months, so that's why you've got 2 semesters per year. Then you're going to say mathematically 5 over 100 multiplied by, this is 2 over 1, then when you change this, it's going to be 1 over 2. Then 5 times 1 is going to be 5. 100 times 2 is going to be 200. That's why I'm saying when they give you a rate or a percentage, you're going to take that and then divide by 200. So just know the basic rule that you're going to divide by 200. Then when they say compounded quarterly, it means you're going to you've got 4 quarters in a year. You're going to say R divided by 400. From that, mathematical procedure, you just have to know that. And then number 4, when they say monthly, we've got 12 months in a year, so we're going to say R over 1200 because it's 12 according to that. And then number 5, they can say weekly to you, then it means your I is going to be R over, you've got 52 weeks, so it's going to be 5200. Then they can say daily, you've got 365 days, so you're going to say R over 365. Then you just put all of them, you just put the 2 zeros, you divide by 2. It's 2 semesters, 4 quarters, it's 2 semesters, 4 quarters, 12 months, 52 weeks, 365 days. And then a year, 1 year, annually, it's a year. Good. Now, we're going to also learn about a formula known as to convert from nominal and effective. Nominal and effective interest rate. Interest rates. The formula is 1 plus I effective is equals to 1 plus I nominal. They give you a nominal all over m, exponent of m. You have to know this formula. When you calculate the effective interest, this is the effective interest rate, that is the nominal interest rate. So when you calculate the effective, you're just going to say I effective is equals to 1 plus I nominal over m. Then you take the 1 to the other side, then it becomes minus 1. Then you just punch in your calculator. So let's look at the following, which is depreciation. Grade 11s, this is a new concept for you, depreciation. Depreciation is when something, or when a product, not a product, but when something loses its own value. It loses value over a certain period of time. Meaning that you know for a fact that we can buy iPhone 15 about, let's say, 40,000. iPhone 15, let's assume it's 40,000. Now, after 5 years, you must know that the value of that iPhone will not be the same as it is now. It will have been reduced. The price will be lower than as it is now. So that is called depreciation. Also with cars, they depreciate in value. Also with what? There are a lot of things which depreciates. Laptop, also what? Shoes. I don't know about clothes. I don't know about clothes, whether they depreciate. They don't depreciate. I'm not sure about that. But just note that the depreciation is when something loses its value over a period of time. So here we have A, also P, I, and N. Your A is not the same as the one in simple and compound interest. The A here stands for the scrap value, the value which that something, that laptop, that computer, that car depreciated, that value after that period of time. So it's a scrap value, it's a book value. Then P is the principal amount. So be careful here in depreciation. The book value is always smaller than the principal amount as compared to simple interest and compound interest, whereby the accumulated amount, the A is bigger than the P. Here the P is bigger than the A. Then I is the rate of depreciation, N is the number of years. The linear depreciation, there are two types. The linear depreciation is A is equals to P 1 minus I exponent of N. Here, remember depreciation, the formula now changes. Remember, oh sorry, I made a mistake. It's a linear, not exponential. It's going to be multiplied by I times N, just like the simple interest formula, but here it's a minus sign for linear depreciation. Then for reducing balance, it's like compound interest but with a minus sign. So it's going to be A is equals to P 1 minus I exponent of N. The question might specify for you, calculate the scrap value using reducing balance depreciation. That's when you're going to use the formula for depreciation. I hope it is clear. For reducing balance. Then for linear or for straight line basis, you're going to use that one. Oh, I've already done compounding periods. So we are good here. Remember compounded annually. You say I is equals to R over 100. You divide by 100. There you divide by 200 for semi-annually. Quarterly you divide by 400. Monthly you divide by 1,200. Weekly you divide by 5200, and then there you divide by 36500. So I hope it is clear. I've also done the nominal and effective interest rates, so we are also good. Example number 1: calculate the effective interest rate per annum if an investment ends. If they want the effective interest rate, it means they have given you the nominal. This is the annum for you. So you're going to use which formula? Remember? We're going to use which formula? 1 plus I effective is equals to what? 1 plus I nominal over m exponent of m. Then you transpose the 1. You calculate, remember the effective. I effective is equals to 1 plus. What is your I nominal? Remember, you don't have to put a percentage. You're just going to say 11.5 divided by compounded monthly. Monthly, remember I said you take your percentage, then you say over 1,002. Remember me, ne? Exponent of, then you just write 12 because it's monthly. 12 minus 1. Then you punch in your calculator. What is the value there? So it's going to be 0.12125 blah blah blah. We don't need this, so you are also going to multiply this by 100 such that it becomes a percentage. Then it's going to be 12.13%. That is the effective interest rate. And let me teach you something very important. The effective interest rate is always bigger than the nominal. You can see, you will observe when you do your calculations that the effective interest rate is always bigger than the nominal. Next question. Thanduxolo bought a computer for 4,700. The value of the computer depreciation at a rate of 18% using the reducing balance method. Now they are telling you to use the reducing balance. It is the one with an exponent. So already you write your formula. A is equals to P 1 minus I exponent of n. Calculate the book value. It means the value for which this computer would have been depreciated. After a certain period of time, they want to know value in working this computer. I don't know if I'm making any sense. The book value, the depreciated amount. So they want A there. You have P. You have your P, which is 4,700. 1 minus your interest is 18% per annum. So 18 over 100. In depreciation, there's no such things like compounded monthly, compounded semi-annually. Yeah, we are not talking about the interests. The compound interest and the simple interest where we use, compound interest especially. Here we are just going to focus on what? On annual basis. To the exponent of what? N, which is 4 years. That's it. Then you punch this in your calculator to get 2124,97. Can you see something? The computer was 4,700. But now look, after 4 years, the value depreciated. This laptop, because of it recedes, if it so that's why the value, when I buy it from you, nka se reke at the same price as the way ke rekileng ka teng. It was 4,007 when I bought it, but when I sell it to the other person, I would not use that same amount. So it tla be depreciated to the other value, which is now 2.1. Next example. Mr. Motumi. Now this one's key, the timelines. We are going to focus on the timelines and different compounding periods. Sorry, be careful. Mr. Motumi made an initial deposit of 20,000 Rand into an investment account that paid an interest at the rate of 7.2 per annum compounded monthly 4 years after his initial deposit. Now, he withdrew 2.5 from his investment. Now, before you can go to the question, you have to draw a timeline. Let's look at the timeline. Now, okay, calculate how much Mr. Motumi had in investment account after 2 years. Okay, so the whole, it's A and B. Oh, you must look at the question, sorry. How much will the investment be worth after 7 years? Now, the whole period is 7 years. We're going to do 1, it's 1, 2, this is T0, T1, T2, T3, T4, T5, T6, T7. Then he made an initial deposit of 20,000. You write plus 20,000. Now, at an interest of that, 4 years after his initial deposit, he withdrew 2.5. At T4, you write minus 2,500. Because he withdrew. When they say deposit, you just write plus. Be careful. The interest is 7.2. I think the whole, not the whole interest. The interest did not change. Let me check. 7.2. I did not write the question correctly. The interest changed. It was supposed to say the interest changed to 7.8% per annum, compounded monthly, for the rest of the period. For the rest of the period. I don't know. For the remaining 5 years. Okay. Now, they say calculate how much Mr. Motumi had in his investment account after 2 years. Account 2 years after the initial deposit was made. So they say 2 years. So it means we're going to say, okay, we're going to calculate using compound interest the value which will be year. And then also use this value to calculate the value which should be year. Then you subtract 2.5. Let's look. The compounding period for 2 years. For 2 years, it's I is equals to what? 7.2 over what? Over 1,2. Then for the remaining period, for these 2 years, it's that. For the remaining period, the interest changed to what? To become 7.8 over 1,2. So be careful. Yeah? For which number of years? Your n is 5. And then there your n, it's for the first 2 years. Your n is 2. So the whole period is 7 years. So let's find the answer for the first question. It's going to be A is equals to P 1 plus I exponent of n. We always use compound interest when it comes to these questions of the timelines. Now, so your P, Mr. Motumi deposited 20,000. 1 plus the interest, remember, it's what? It's 7.2 over 1,2. Exponent of n is 2. Now you always make sure you multiply by the, if you divide it by 1,2, you're going to multiply by 12 there. Be careful. Then you punch everything in your calculator. You punch everything in your calculator. There's no quarterly, yeah, it's fine. Then you get the answer of what? Of, let me punch in your calculator. 20,000. 1 plus 7.2 over 100. Exponent of 2 times 12. We get 106,097,43. That is the value which will be here. 106,097,43. Then you use this amount again to complete, to come to this term after, and then you subtract the 2.5 to just complete everything. So it will be our next question. So this one we are done. You've answered the question. How much will Mr. Motumi have 2 years after the initial deposit? You are fine. How much will the investment be worth 7 years after the initial deposit? So you have to complete everything. You continue. A is equals to P 1 plus I exponent of n. Your P is what? You use the very same amount. Your P now, you use this value. That is your P for now. It's going to be 106,097,43. 1 plus, remember the interest now changed. That's 7.2. This 7.2 was for the first 2 years. Now for the remaining time, you're going to use 7.8%. So that's why it's going to be 7.8 over 1,2 to the exponent of n. It's for, now it's again 2 years. 1, 2. 2 years. 2 multiplied by 12, remember. Then you punch in a calculator. 1 plus 7.8 over 100 exponent of 24, or exponent of 2 times 12. I made a mistake, sorry. 106,097,43. 1 plus 7.8 over 1,200 exponent of 24. I get a value of 1,23946,870. Now minus 2,500, withdraws 2,500. You subtract the value, minus 2.5. Then the answer is 1,21446,870. This is the value that will come here. Then you complete using that value to find the remaining period, which is 1, 2, 3. The last 3 years now. The last 3 years. Remember, first question, it was 2 years. Then from year to year, it was 2 years. Then the last is 3 years. So 2 plus 2 plus 3 is 7 years. So we complete. Therefore, A is equals to, you write the formula again. You use the very same amount to come here. 121,446,870. 1 plus the interest still, it's still 7,8 over 1 down 2. Exponent of n now is 3. It's 3 multiplied by 12. Then you write it, you punch in your calculator 121,446,870. 1 plus 7.8 over 100. Exponent of 3 times 12. Then now the value at the end of 7 years, or in 7 years time, it will be 181. 4102,062. It will be 1,814,102 rands. Yeah, 814,000, sorry, 102 rands. So that will be your answer. I hope it is clear. Next question. A company bought a machinery costing 80,000 using linear depreciation method. We're going to use a linear depreciation. Calculate the rate of depreciation. They want the I. Now, if the book value, remember it's A, that will be your P. Remember I said P is always bigger than the A. And then this is your N. Linear, remember it's A is equals to P 1 minus I exponent of N. Remember when I first taught you that linear depreciation. Then it's going to be A, it's 20,000, P is 80,000, 1 minus, we are looking for the rate, I, exponent of 5. The simple step here, you're going to divide both sides by 80,000. Then it cancels off. You remain with 1 minus I exponent of 5 is equals to, you punch this in your calculator, we're going to get 1 over 4. Yes, 1 over 4. Then to remove the exponent of 5, you insert the fifth root both sides so that it cancels off. The 5 kills the 5. Then you remain with 1 minus I is equals to, you punch this in your calculator. You are going to get oh, I made a mistake. I'm so sorry. I made a mistake. You are supposed to use the linear. I can see. So it's going to be, we're going to use a linear depreciation method, which is A is equals to P 1 minus I. I love the exponent. I N. Then your A is 80,000 is equals to, I'm making mistakes. I'm sorry. Your A is 20,000. Your P is 80,000. 1 minus We're looking for the I multiplied by 5, the number of years. Then you divide both sides by 80,000. It cancels. Then you remain with 1 minus 5i. I times 5 is 5i. Then when you punch this in your calculator, you are going to get 1 over 4. Then you transpose the 5i to the other side, then the 1 over 4 to the other side. Then it's going to be 5i is equals to 1 minus 1 over 4. If I'm correct, then 5i is going to be 1 minus 3 over 4, which is 0.75. Then you divide by 5. Then I is equals to 0.15. Then you always want percentage. Then you multiply by 100. Then I, or we can say the rate, which is R, is equals to 15%. Then you are done. Next question. Calculate the effective interest rate if the interest is compounded at 5% per annum compounded quarterly. The formula is what? Remember, 1 plus I effective is equals to 1 plus I nominal over M. Then we look for the effective interest rate. So we're going to transpose the 1. So it's going to be I effective is equals to 1 plus, what is your nominal? It's 5%. So it's going to be 5 over quarterly. Quarterly means what? Quarterly means you divide by 4. So it's 400 exponent of 4 minus 1. Then you punch in your calculator. You are going to get the effective rate of 0.0509 and so on. Remember I said when you get this, you multiply by 100. Then it's going to be 5.09%. Remember me, I said the effective interest rate is always bigger than the nominal. Look at the effective is 5.09. Then the nominal was just 5. Meaning that this one is bigger than that one. Next question. Again, we are going to do timelines. Sipho invested 30,000 for 6 years. The total is 6 years. Calculate the value at the end of 6 years. Now, we are going to draw a timeline. Start with T0 up until T6, T1, T2, T3, T4, T5, and T6. So initially, invest 30,000. The investment earned an interest of 12% per annum, compounded monthly, for the first 2 years. 1, 2. The interest is what? 12%. It means it's 12 over, and then compounded monthly. 12 over 1/2. First 2 years. It means N is 2. Thereafter, the interest rate changed to 10.8% per annum, compounded semi-annually for the rest, meaning that for the rest of the period, the interest changed to 10.8 over what? They said semi-annually. Semi-annually means you're going to divide by 200. Then N is equals to what? 1, 2, 3, 4. 4 years. So 2 plus 4 is 6. Now they say what? Calculate the value of the investment. Now remember here, you have to find the value from year to year, then you write it year, 2 years. Ne? Then that value you're going to use it to complete up until it comes there. There are no withdrawals and deposits, so this one is easy. So it's going to be what? For the first 2 years, A is equals to P 1 plus I exponent of N, which is 30,000, 1 plus. Guys, when you have completed your timeline correctly, then the calculations are going to be easy for you. 12 over 1,2 exponent of what? 2 times 12. Remember, 2 years times this 12. Then you punch in your calculator. You are going to get 38,092 rands, comma 03. I advise you to write at least 5 decimals for accuracy, because you're going to use this answer. Then you're going to use this answer. It comes here. The very same answer you complete for the rest of the period. So it's going to be A is equals to P 1 plus I exponent of A. Then it's going to be what? What is your P now? 38092, 03946. 1 plus, what is your interest? It changed from 12% to 10.8. 10.8 over 1,002. Now your N is what? 4 times 12. 4 times 12. If I'm correct. No, why 4? Sorry, not 12, guys. I made a mistake again. I do make mistakes, guys, so please bear with me as long as I can realize them. So it's over 200 exponent of 4. Where do I get the 4 now? Oh, 4 years. 4 times 2, because of 2 comes there. Then you punch in your calculator. Then the final answer is 58,017,51. That is this field, it will come here. So at the end of 6 years, this person will be having 58,000. The next question, it's also timeline. So let's start. You're going to draw your timeline. You check the whole investment, the whole period. I look, okay, I see 2 years, I see 3.5 years. Now the total, what amount will Mary have? 5 years. It means T0, T5, T1, T2, T3, and T4. Now, she deposits what? 25,000 with an interest rate of 18% compounded monthly. So I think, okay, there is no point whereby the this interest rate changes. So it means for the whole period, the interest is what? 18%. So it's 18% compounded monthly. So 18 over 1,002. Now, Mary withdrew 8,000 from the account 2 years after. Add T2 minus what? 8,000. She deposited another 4,000 into, hey, Mary is not a male, into her savings account 3.5 years after the initial. So you move, this is term 3, T3, 3 years, so 3.5 will come here, which means she deposited what? 4,000. So we're going to calculate the value from here up until here. Then you subtract the 8,000. Then that answer, you're going to use it from here up until here. Then you add that answer with 4,000. Then that answer you get, you're going to use it from here up until the last. Let's start. A is equals to what? P1 plus I exponent of n. What is your P? 25,000. 1 plus the interest, remember it remains the same, which is 18 over 1,002. Now your n for the first 2 years, this is 2 years. Now the years here, it's 1,5. 1,5 from this. This is because this is from year to year it's 1. Then from here to here it's 0.5, so it's 1,5. Then from here to there, or let's do from here to here also, it's 1, it's 3.5 to 4, it's 0.5. Then there it's 1. It's also 1.5. 1.5, it's 3 years. 3 plus 2 is 5 years, all in all. So your n for the first 2 is 2 times 12. And then you get what? You get 3,573.5703. That value will come here, and then you subtract 8,000. Then you get a new value, which is 27,737.5703. This value, you're going to use it. You're going to use it from here. It's a value which should be here to get the value up until there, I think. Yeah. Then you're going to say A is equals to P1 plus I exponent of n. Your new P will be that amount, which is 27,737,5073. 1 plus the interest remains 18 over 1,002. Now the n is 1,5 times 12. Then you're going to get the value of what? A new value, which is 36,262,45279. What happens when the value gets there? She deposits another 4,000. Then the new value will be what? It will be 40,262,45279. It's a new value, which will be yeah. Then you use this value, last one, to go there to the end, or the end of 5 years. So you're going to say what? Therefore A is equals to P1 plus IN. You're going to use that value, 40262,45279. 1 plus 18 over 1,002, exponent of what? Also the remaining period is 1.5. 1.5 times 12. Then at the end of 5 years now, she will have 52,636,74. You can round off your final answer to 2 decimal place at least. Then you are done. Example 8. A school buys tablets at a total cost of 140,000. If the average rate of inflation, guys, remember I told you something about inflation. When you see the word inflation, it means you're going to use compound interest. Remember from my notes that you use compound interest when you see the word inflation. Simple interest when you see the word hire purchase. So let's look at this. Now the formula is going to be A is equals to P1 plus I exponent of N. Now this is the value. They want the cost of replacing these tablets in 4 years. It means they want to know how much will these tablets cost in 4 years. What will be the value in 4 years if they buy them using the average rate of inflation as 6.1. So your P is going to be 140,000. 1 plus the average rate of inflation is 6.1 per annum. It's per annum. It means you divide by 100. It's not compounded monthly, semi-annual. So you divide by 100. So it's going to be 6.1 over 100 to the exponent of 4. You don't have to multiply anything there because it's only 1 times 1. It's like that. Then you punch in your calculator, you're going to get that these tablets will cost 177,414,69 after 4 years or in 4 years time. Then example number 9. An investment earns an interest rate of 7% compounded semi-annually. Remember, I is equals to R over 200 divided by 200 semi-annually. Calculate the effective annual interest rate. Formula is 1 plus I effective is equals to 1 plus I nominal over M. Then you transpose the 1. I effective is equals to 1 plus. This is your I nominal, 7 over compounded semi-annually, 200. Exponent of 2 minus 1. Then you punch in a calculator. You're going to get 0,071 something. Then you don't want it like this. You're going to multiply by 100. Then your final answer will be 7,12%. Remember, I effective is always bigger than the I nominal. So that's how you tackle this problem. Ladies and gentlemen, I will continue with the other examples in my next video, especially for grade 12, where we'll be focusing on future value and present value annuities. So thank you so much. You can try this example 10 whereby you use a timeline. It's for 4 years, so it's going to be T0, T1, T2, T3, and T4. And then the deposit is 24,000. 18 months later, 7,000 was withdrawn. 18 months is 3, let me just check. 18 divided by 12, 1.5 years. So it's 1.5. So it's 1 year, 6 months. So it's going to be there 1.5. So you withdraw 7,000. Calculate how much money will be in the savings account at the end of 4 years. Interest remains the same. Interest 10.5 over, it's compounded monthly, 1/2. Then the period, you're going to find the answer from year to that 1.5. So N 1.5. Then from year to the other one. So your N there would be, this is 2 years plus this 0.5. So it's going to be 2.5. Because 2.5 plus 1.5 is 4 years. So you're going to find the answer from year to year using the formula. Then your answer, you're going to subtract 7,000. Then your answer again, use it using the formula to get the remaining part. So look at the question carefully and try it. Thank you so much. Till we meet again.